The last part of geometry of straight lines is all about parallel lines. And under parallel lines, we are actually working with three different types of angles, three different theorems that we will be working with. So you might have heard, or probably I really hope you've heard of fun, okay, where we have our corresponding angles, our co-interior angles, and our alternate angles. In this video, we are going to look at just the first one. We're going to look at corresponding angles. Corresponding angles is the F shape that you look for in parallel lines. So if we have this parallel line over here, your corresponding angles would refer to, if you look at the F shape, something like this, then the angles underneath, I often tell my kids, I think of the angles underneath the armpits of the F, both from the same position, those will be equal to one another. They are always called corresponding angles. So even if you have lines that are obviously not parallel, this angle and this one, they are corresponding angles, but you can clearly see they are not equal. This one you can see is an obtuse angle, whereas this one is an acute angle. But yeah, so it's the parallel lines part that makes them actually equal to one another. So that's our F from our fun. Let's look at like the theory part of this. So if it is given to us that lines are parallel, then the corresponding angles will be equal to one another. And your reason will be corresponding angles with the parallel lines. You have to have it there. You can also abbreviate corresponding as CAR. That's also fine. So yes, the parallel lines are very, very crucial. So if you look at this sketch, the F can be in any of the four different ways. Oftentimes, if you're struggling to see it, turn your book around, okay? Make it look familiar. And yes, so I think I did say earlier, it's all about position. That says position. And it will be the angles that are on the same side of the parallel lines and the traversal. But we also have the converse of this theorem, which is if you want to prove that the lines are parallel. If we want to prove that the lines are parallel, you need to first find the corresponding angles, prove that they are equal to one another, and then you can say that the lines are parallel because the corresponding angles are equal. Okay, you don't have to add the word are there, but I think it helps sometimes if you have it there, just like for sentence reasons. So the reason, if it's parallel, why the angles are equal is because the corresponding angles and the parallel lines, it's the two together, because the one on their own is not going to help you. But to prove parallel, it's because the corresponding angles are equal, not because the corresponding angles and parallel lines, because you will prove in parallel lines. Okay, we'll get to an example in a moment. Okay, so let's first do two examples where we are using the fact that lines are parallel. So if we can find corresponding angles, they will be equal to one another. And then we'll look at an example where you prove the lines are parallel. In this first sketch, we see the parallel lines here. So it always has to do with the traversal, sorry, not traversal, transversal. If you can make the lines of the F on the parallel lines, and then the one that comes down to the ground on your transversal, then on the same position. So underneath the armpits of the F, those will be equal. So that means that X will be equal to 63 because they are corresponding angles. But corresponding on its own doesn't mean they're equal. It's this corresponding with the fact that the lines are parallel. So then we add AB is parallel to CD. Okay, also, I think I forgot to mention this earlier in the video. We indicate parallel lines with arrows and equal sides with lines. So arrows mean parallel even if it wasn't like specifically written out for you. Then, okay, now we've looked on this side. We found our F, but on the other side, we can also draw an F. And also underneath, we will get that y and 71 are equal to one another for the same reason. And it's the same parallel lines. Sometimes it helps if you cover a portion of the question with your hand. Just look at one side and then you go over to the other side. That's why I drew the little squiggly line in between. Okay? This 71 and this x have nothing to do with one another. Similarly, this 63 and this y have nothing to do with one another. Okay? Because they're on opposite sides. It's different transversals, all of that. You look at example 7a. Here again, we have 3 different transversals. So each of them you need to look at on their own. We have the parallel lines. So this entire line and this entire line are parallel. So we go look at one transversal at a time. Here's our first transversal, and we can see we can make an F this way around for us to have information in it. Then we'll have that x and 50 are equal to one another, corresponding angles with their parallel lines. It's the same name as in the previous question, which is just lucky more than anything else. Then we've now already looked at this transversal, was the only information we can get here. All the other angles were empty. Then on this transversal, the angles that are like adjacent or touching this transversal line is there by y and by 120. So y and 120 will be equal to one another. And you can make this F a bit longer here so we can clearly see it's an F that goes that way. So y and 120, exactly the same reason. And yes, it doesn't matter if it's 5 of the same reasons. You have to go write it every time. Okay? As much as we've said earlier that mathematicians are oftentimes lazy for writing, when it comes to reason, unfortunately, you must go for it. You only get away with like writing abbreviations, but right? You were right. And then we've now looked at this transversal. Here's our last transversal. And if we see, we can draw lines this way, then Z and 110 will be equal to one another. And also exactly the same reason. And yes, you have to go write it again. Also, I'm not sure if I mentioned this earlier, but this is our symbol in mathematics for parallel lines. Maybe a little late to say it now, but rather late than ever. Here we have one more question. Okay, we said earlier this question is not a finding x or y or whatever variable type of question. This is the type of question where we have to prove or show. Okay, in this case they are using the word show because in grade 8 you will often not or very rarely see the word prove, but show, prove, same thing in this case. So we have to show that the lines are parallel. Okay, so when we are trying to prove or show something, you cannot assume in order to prove. Okay, you can't use the fact that it's parallel to prove that it is parallel. That is circular reasoning. It is also something we went over when we were doing straight lines. Well, we don't do that, not because, well, yes, it is mathematically not correct, but more than that, it's logically not correct. And even if you never use maths after school, at least we need to learn you or teach you the things maths does to your brain. That's important. You might not have to prove something one day that is mathematical, but you will have to be able to reason, and discussions will need to have happened and whatever. Anyway, irrelevant. Let's move on. And by move on, I mean like do the question. Okay, so we have steps here. And I think maybe we need to dot them down as we go along. So our first step when proving parallel is you are going to identify if we're using F, U, or N. We will get to U and N later. In this case, it will be F. So we're identifying F, U, or N that has bits of information in it. So in this case, we have 1, 2, 3 angles. So of the 3 angles, 2 of them will be in our F, our U, or our N. Let's call them angle 1 and angle 2. Then we use angle 3, our third angle, with angle 1 or angle 2, we see which one, to solve x. We cannot use any of the parallel line properties to prove this or to solve x, because then you are assuming parallel to prove parallel, okay? Remember, that's not logically sound. So it's usually either going to be angles on a straight line or vertically opposite angles. So now you solve x. Once you have x's answer, you will substitute it into angle 1 and angle 2. Okay, we substitute. Then if it's f, which we are busy with now, then you will say angle 1 is equal to angle 2, and therefore whatever parallel line is parallel to whatever other line, with your reason, which is that the corresponding angles are equal. Okay, these are the steps that we're going to run through. We said, okay, in this case it has to be f. Okay, we haven't done any of the others yet. So here along our transversal, we know we're going to color that in, and then we see on top here, on top of both parallel lines, we have bits of information. So this is our angle 1 and our angle 2. Okay, we cannot equate them to one another. We can only use one of them along with our third angle to be able to solve x. Only one of them. And in this case, we're going to use 2x because they are angles on a straight line. So we need 2x and 3x plus 80. When we add them, we get 180 because they are angles on a straight line. Here we see we have 5x plus 80 is equal to 180. And then over here, happening to x is a times 5 and a plus 80. So we are going to minus 80 and then divide by 5. So x is 20 degrees. Okay, now we've done this first step, we've done the second step. The next thing is to go substitute back in. So angle 1 and angle 2, the one that are here in green, the ones that are here in green. Okay, you can see they were actually nice to you. They gave you names. This is F1, not 1, F1 and E1. I gave you names. So F1 is 3. We leave a space for x, brackets, so we can substitute, minus 20. And E1 was 2 times x. So we put brackets there so we can substitute. Okay, and in both cases, we can substitute 20 in x's place. And in both cases, we will get 40 as an answer. So now we can see that the two are equal to one another. So we write it down. We are writing down what we are seeing, and that is that the two angles are equal to one another. And we know they are corresponding. Even without the parallel lines, we know they are corresponding angles because they're on both sides of the lines that cut the transversal, that cut ST. So they're on the both sides. So they are corresponding, and we just now prove they are equal. So because of this, we can say that, what is the lines called? Yes, okay. Same as the whole time now. AB, we can say is parallel to CD because the corresponding angles, we just calculated that those angles that are corresponding are in fact equal. Okay, so let's just take a moment. Do we see the difference between when it is corresponding angles are equal and when it's corresponding angles and parallel lines? It is all about what you are given or what you know at that point. So here in both of these examples, we were given that the lines are parallel, so we know it. It's not an assumption, it's something that was told to us. It was embedded in the question. Whereas here, it wasn't given to us. It was asked for us to show it. They literally just said AB and CD are straight lines, and it's cut by a transversal ST. That's all. So the only thing we knew was that those are corresponding angles, and then we went to do calculations and we calculated that they are equal to one another. So that is why we use the reason corresponding angles are equal. We calculated it, we showed it, we proved it. Okay, in the next lesson we will be looking at alternate angles, and then co-interior.